Okay, now we're gonna look at ladders. So this is a ladder, and it's got 1, 2, 3, 4, 5, 6 steps. You never notice the difference. See, this ladder has steps on both sides, so someone can climb on each side, which could be useful if like if you're working on something heavy. And then on this ladder, it can only work on one side, but we've got a tray. So you never climb the top 2 rungs of the ladder. And then I've worked at, say, Shell and Dow Canada, Shell Canada, Dow Chemical. They say you can't climb the top 3 steps. So you can only climb up to here at a Shell plant. And this helps you stay balanced on the ladder. So if you need to go up more, you get a taller ladder. But generally, um, a lot of big employers, especially industrial, don't allow you to work off a ladder. You can use a ladder, say, to look at something or inspect something or check something. But if you want to actually like use a tool, since you need to be, you gotta use either scaffolding or a scissor lift or something else. The ladder is not acceptable, and that goes back to you can't under the code you can't work off more than 9 feet in the air without a harness or being tied off. So you can't work off a 12-foot ladder, for example, because if you're standing 12 feet in the air, what are you tied off to? You can't. There's no anchor point 12 feet up on a ladder. You can't tie a harness to a ladder. And then at a lot of industrial plants, you have to be you have to have a fall arrest system when you're working more than 6 feet off the ground. So ladders basically just don't work at a lot of these industrial sites. Now, we've also got what we call an extension ladder, which is like a really tall ladder. So if we're climbing up a side of a building, again, we want to be safe, so use a 1-to-4 ratio and secure the base, and always have 3-point contact on the ladder. And don't reach over the ladder. You want to keep your belt buckle within the ladder, for example, and the ladder should be 1 meter above the landing point. Now, there are 4 types of ladders which have different capacities. So from 136 kilograms to 91 kilograms, or like 250-pound ladder to like a 200-pound ladder. So depending on what you're doing. Now, ladders can be made of wood, aluminum, or fiberglass. Now, fiberglass is the best because it does not conduct electricity, and it's very strong. Well, aluminum is good too. Aluminum ladders are much lighter than fiberglass ladders, but they do conduct electricity. And so wood does not conduct electricity, and it's really cheap, but wooden ladders can break, especially homemade ones. You can't really buy wooden ladders, but you can buy aluminum and fiberglass ladders. So now, like I said, um, if you can't use a ladder, then you can use scaffolding. So scaffolding must be designed to support 4 times the load. So if it's gonna, if we know we're gonna put 1,000 pounds on it, then we design it to support 4,000 pounds. Now, normal humans don't install scaffolding. You have to hire a scaffolding company to come put the scaffolding together. And usually they rent it to you at like whatever cost it is, and they put it together and they inspect it and they tell you it's good. And that's it. And then you don't have to worry about it. So, but if you do put your own scaffolding, make sure it's level and you have to brace it. Scaffolding can get very complicated and it should not be taller than 3 times its smallest dimension in height. So if it's 10 feet wide, then it cannot be more than 30 feet tall, because otherwise it'll just bend right over, wind will blow it over. So if you want to be 100 feet tall, then you got to be at least 30 feet wide, for example. And then we want to anchor it with wires, so guy wires or tiebacks, at least 4.6 meters vertically and 6.4 meters horizontally. And then obviously when you put the scaffolding together, you should wear fall protection and do not install near power lines. So we've got two types of scaffolding. We've got light duty and we've got heavy duty, and the spans are different. So, but the heavy duty can support up to 367 kilos per square meter. Now, we also have guardrails. So anywhere that we are working that's 3 meters or higher must have a guardrail of at least 1 meter. And there must be an intermediate rail that's horizontal between the platform and the top rail. So we also have a toe board. The toe board, because people like to lean on guardrails because they're stupid. So, and things fall off the edge. So we have a toe board that's like 3 inches tall. And the toe board has to be there when we are 3.5 meters above the ground or when people are working below. You always want to put a toe board. So here's our scaffolding. So what we have here is um, you can get scaffolding with a staircase and you can get scaffolding with a ladder. So in this case, we've got a ladder to take you to the top, and we've put a guardrail with the top rail and the mid rail and the toe board, and we've got some cells to keep it like a mud cell so this thing doesn't sink into the ground, and we've got some anchors to keep it from moving. So this works. This isn't the best. Um, on a lot of, I'm seeing, for example, a train station that they're building, they've got scaffolding, but it's got a staircase. So that staircases are way better for workers because they can carry tools up. You can't really carry tools up the ladder like you can with the stairs. So that's a problem. Now, we also have what we call a rolling scaffold, which is scaffolding, but it's got wheels or casters. Now, it must, again, can't be 3 times taller than the smallest dimension, and you can put the worker can stand on top of the scaffold, and we can push the scaffold around, but only when the floor is really firm and the height is less than 2 times the base. So here's an example of a rolling scaffold, and it's got a guardrail, so somebody can work up top and another worker can move the scaffolding while this guy is still working, and that way he can stay. He doesn't have to get down and move the thing. He can just stay up there. Now we have wood scaffolding as well, and they're really good because see, metal scaffolding comes in pieces like that are pre-manufactured, and we have to put it together. So sometimes it's not easy to build around what we're building. But with wood, we can cut it to size. Now you should use, everything has to be tight, and don't paint it. And we don't want to paint it because we want to be able to inspect it in case it breaks. Any questions?